So the next part in the conic section is to go from what you saw yesterday, which wasn't terribly bad because you had the formulas right there, and it switches it into what is it and what is its graph. So this is what they call standard form of a conic section. A standard form of a conic section is going to look like this: ax squared plus by squared plus cx plus dy plus e is, I think that's what it looks like. If you look at that little cheat sheet thing that I gave you, oh, it's ax squared ay squared, whatever. That circle one is kind of like that, but I believe it should be look like this. But this is a format way that they do write it from time to time because it's basically the factored out version of all your standard, of all the other stuff, of the conic equations that you have. If you look at the conic equations that we have, it's always a quantity x minus h squared plus quantity y minus k squared and things like that. So what they have done is that they've taken what you did yesterday and they basically foiled it out into this. So we're going to factor that to a more user-friendly. That's what we're looking at today. So we need to figure out what that is. Right away, you might be able to kind of figure out what it should be without too much brain power. It's going to be a parabola. Why is it going to be a parabola? You're not stupid, you just didn't notice it. Okay? Don't say that. You're not stupid. There's obviously in this case here, we know it's got to be a parabola because there's only one square term. So it's one of those things that the parabolas are all the only ones that have a singular square. Everything else has two. So here's what we do. I need to make this look like, we know it's an x squared. I need to make this look like this. I need to get it to look like that. That way I know how to graph it. Because that was our generic form of the equation of the parabola. We know it's got to be an x squared term because there's an x squared. Convenient. So here's what we do. In order to do this, we're going to do a whole bunch of complete the square. Since it's a parabola, I only have to complete the square once. If it was another conic section, I have to do it twice. There's going to be a little trick involved here with some of them, but in this case, it's not going to be so bad. So first thing we have to do is we're going to keep the x squared stuff and the x term on one side, because we're going to create a perfect square out of that. And we're going to move the rest of it. I'm moving the y value and the constant to the other side. And then since I'm going to put something in here, I have to put something there. Okay. Now we follow the process of the complete square. And most of you guys at this point are like, oh yeah, complete square. Take half of b, throw it in the parentheses, square it, add it to both sides. It's a process. And that's what's nice. Completing the square is just a straight process. You do the same thing each and every time. Especially, or really the only rule is, that's got to be a 1. It's not a 1, you can't do it. So what's half of 2? 1. You can do it, you have to factor it out, and we're going to do that here in a second. I take half of 2, I throw it in my parentheses, I square it. What's 1 squared? 1. And I add 1 to both sides. Okay. So now on the right-hand side, I have 4y minus 3. You all right with that? We're almost done. What do I have to do now to the right side to make it look like a 4p times the quantity y minus k? Whatever it is, you got to factor out the coefficient of y, no matter what that number is. You always factor out that coefficient of y because it's got to be on the outside. What's the coefficient of the y here? 4. So I factor out a 4, and it just looks a little weird. You get x plus 1 quantity squared equals 4 times the quantity y minus 3/4. And now I know how to set my value for p. Now I know how to find my h and my k, and I go from there. No. So it's a parabola. Which direction will this open? Up. Yep, it's got to open up. It's an x-squared parabola. It opens upward. What's the p-value? 1. Very good. Okay. That's what we're looking at. The graphing portion, I don't think is horrible. We'll do a few graphs here and there, but I just want to get accustomed to seeing how we go through the process. Okay? So it's a parabola. It's got to open up. And we'll just leave it at that for right now. linear then. No, no, there's, in order to finish that one out, you'd have to do a 1/3, 1/3 over 1/3, and then a 1/5 over 1/5. We don't need to graph that one. So let's go to one that I know that we can finish, as opposed to, hey, this one looks nice. Let's try this one. We haven't done one like this yet. Yeah, apparently. What's that? Yeah. And you'll see that it's a lot of it's 4s, 9s, 16s. All right, first thing we're going to do, put everything in order. 4x squared minus 48x, bless you, y squared minus 4y is a negative 48. All I did there was moved all the x's together, y's together, move my constant to the other side. Now, we have an x squared and a y squared term, so it's going to be a circle, ellipse, or a hyperbola. We can't make a definitive answer to what it's going to be yet, because there is an occasion where sometimes when your constant value, if it's negative, sometimes you flip things around. You can wind up with what started to look like an ellipse, and it can wind up being a hyperbola because of the way the negatives work. You can flip-flop x's and y's. There's a lot of weird stuff that can happen. So we go through the process. We know here I'm going to have to factor out a 4. And I wind up with that. I'm automatically setting myself up to complete the square. As soon as I take that 4 out, I'm writing it as, well, 48 divided by 4 is 12, and I know I have to have a plus blank for completing it. On the y squared front, I don't have to factor anything else. It's got a coefficient of 1 to start with. So I'm going to have a y squared minus 4y plus a blank. On the right-hand side, we have already a negative 48, but I have to put in a plus 4 times something and a plus something, because that's what I took out. I got to put back. Okay? Whatever you take out when you factor out, you have to put back in the portion of it, because remember what's happening. Whatever I get here, half of negative 12, when I square that, I get 36. So technically, this side would have been 4 times 36. That's why I have to put it on the other side as well. That's how that works itself out. So I put a 36 over here. And then the 4 is still out in front. Half of negative 4 is negative 2. I square it, and I get 4. All right, well, let's see here. If I double 36, what do I get? Double that, what do you get? You know, if you only had that calculator. So 4 times 36 is the 144. Nice. I hear that thing's awesome. Add 4 to that, you get 148. Subtract 48, and you get... Huh. Isn't that convenient? And a lot of them are. Okay? To be honest with you, if you get really crappy numbers, you've probably done good something. So that example, like that last problem, we didn't goof. It was just really bad numbers to begin with, okay? I promise to give you stuff that looks normal, at least today. How quickly you guys turn on me.
Well, you said at least today. We have it later.
Turn on us.
Yeah, because I have to turn around to use the smartboard. Ooh, Murphy. So now we have the quantity x minus 6 squared over 25 plus y minus 2 squared over 100 is 1. I simplified the 4 in the 100. ¿Qué es esto? Es uno elipso. ¿Cómo se dice ellipse en español? Anyone? El ellipso? What direction is it being stretched? Up and down or left and right? Up and down. Why is it being stretched up and down?
Okay.
Where is your center? A squared is? It's 100. B squared? What's C squared?
25.
75, very good. A is plus or minus 10. B is plus or minus 5. C is plus or minus 5, 3. Did you figure out the rest of ordering? Yes. I'd like ordering some pears, please.
Sorry, we're all out.
Are pears in season right now?
That's not here. Apples. Honey crisp apples.
Aldi had Honey Crisp apples on sale for like a 3-pound bag for $1.99 last week.
What?
Yeah.
Go to John Mac Orchard. Honey crisp apples.
Are you being paid? I'm getting paid so much. He's walking around with putting business cards here. Go get a.
Paid one apple.
Unless it says you're at. I've never signed a Not yet. I'm just. All right. You do it. Height is usually getting the border.
I know I'm doing it wrong, but I want to at least finish
Wait, yeah.
Oh, I see what I did. Oh, I did.
Did we get to that?
I didn't have it.
Yeah.
Usually on one like this, what people mess up is right away when you take the -9 out. When you factor out a -9, you forget to take out the negative out of the 36. And that's usually where people mess up. And what happens then, if you do that, you wind up with the wrong ordered pair. But you can still do everything right, but you make the one dumb mistake. And that's the thing here. You got to be very, very cautious in how you do your steps. So now you divide out by that 144. got that part right. Thanks.
I think I messed it up.
So that's what? Y minus 2 quantity squared over 36. This would be a negative. Is it 64? Oh, 16. I have. Now, what do you do?
You don't call it an ellipse.
Switch them. It's not an ellipse. What's that? You switch them. Haley's throwing down back there. Take that, man! I'm better than you. That's what she's saying in her head. It's okay. That's a hyperbola. What direction is he going? Somewhere in the plane of space, yes. Where did I get the negative from? Yeah. What's negative 9 divided by 144? It's negative 1/16. What's negative 1 plus 2? I didn't know if your upgraded calculator could do that problem, so you might want to double check the upgraded calculator. So negative 1 plus 2 is the same thing as 2 minus 1. I'm just making numbers up to try to help your brain. The commutative property of addition. So that's that little trick that sometimes you'll see that. Now, I will tell you this, sometimes this could wind up being a negative, when you divide out to begin with, you could be dividing by a negative to make that positive, where it changes both sides and you have to do a flip. So just be careful when you see those negatives. So that's a good question where it makes you switch. No, I actually use the commutative property of addition, because 3 plus 2 is 2 plus 3. Well, I can save your search. What's 2 plus 3? What's 3 plus 2? Does the order matter? That's fine.
It's not rocket science.
Rocket science is when you have to talk about a lot of stuff. This is just addition.
Rocket science has parabolas.
So, what I want you guys to do, yeah, it's still 10-6. A whisper edition. Have you ever been to the one of the museums where if you just it's the sound waves that how things bounce through.
Because you're saying that it's focused point.
Right.
And it goes in like perpendicular, parallel to what you're talking about.
And that's when you're talking about the focus of the parallel to where you're talking. You're speaking about the lattice rectum. And I'm not lying. That's exactly what you just described. Because
I'm good at describing
if the lattice rectum is the segment that goes through the focus, that's parallel to the minor axis. So as you're at this point, you are perpendicular there, and your parallel is in this. And that's why it bounces and it comes back here, and it comes right back to the other focal point. That's why all it works.
There's like a white dot. No matter how you do it.
Oh, no, I haven't seen that. That's cool. That's very cool. Hey, just in case you ever wanted to know how to find the length of a lattice rectum,
Rectum.
damn near killed him.
He said an organ.
I didn't say a Wurlitzer. Thank you. Thank you. Oh, you could have said yes. I was laughing at your Wurlitzer joke. I want to say it was. I think it's two. I think it's 2a squared over b. Yeah. Pat, thanks for getting me back on track because I get sidetracked. Homework-wise, you saw me press copy, right? It's the same. It's the same page on 10.6 that you guys were working on. I think it's just the next page over. So whichever one that was. It's just still 10.6. Put these into a workable graph setup. And what I mean by that is the formats that you know.
Oh.
Yes.
So we don't have to like actually.
Yeah. I would like you to graph those two. I want you to graph those two, which means label everything. Okay? Yes, sir.
So can you, as a math teacher, be able to identify from this?
From this stage, most of them.
What's neat?
There is a way to do that by looking at the discriminant of a conic section. There's a whole other way of doing it, but why memorize all it out when I'm still going to ask you to graph it? You know what I mean? Because a lot of times if you get going, you can just kind of start your setups. Even if you don't complete the square fully, if it's just what conic section is it, you can kind of fudge your way through it. I mean, on 51, what is it? It's a parabola. 53, you'll notice that you have a minus y squared. So it's a good chance it's either going to be a hyperbola or an ellipse, unless there's one of the tricks. All right, we'll go through those, see how we do. We'll probably do more of this tomorrow, no big deal. I think what we'll have to wait on, we'll probably wait on writing equations till Monday. Shouldn't be a big deal. Go from there. Okay. It will work. I don't think the conic one will work on that one.
Weird.